This is a question that leaves 90% of students back. Is 4 square root 2 an irrational number? And if so, how do we prove it? If you're ready to rise above the crowd and join the top 10% who can crack this, you're in the perfect place. All right, before we jump into the proof, let's get the basics down. Numbers are like two teams in a game, the rational numbers and the irrational numbers. Rational numbers are the chill ones. They can be written as a fraction, like PQ, where P and Q are integers, whole numbers, no decimals, and Q isn't zero. But here's the secret sauce. P and Q have to be coprime. Don't panic if that sounds fancy. It just means they share no common factors except 1. Think of 3/5. 3 and 5 only have 1 in common, so they're coprime. Easy, right? On the flip side, irrational numbers are the wild ones. They can't be tamed into a simple fraction. They just keep going like pi or square root 2. So where does 4 square root 2 fit? Let's find out. To figure this out, we're going to play a little detective game called Proof by Contradiction. It's like saying, okay, let's pretend 4 square root 2 is rational, and see if that makes sense, or if it totally falls apart. Spoiler, it's going to get wild. First, let's tweak 4 square root 2 a bit. Notice that 4 equals the square root of 16, so 4 square root 2 equals the square root of 16 times. The square root of 2 square root of 16 times 2 equals square root of 32. Same number, just a cooler outfit. So proving 4 square root 2 is irrational is the same as proving square root 32 is irrational. Let's roll with that. Here's where the fun starts. Let's assume the square root of 32 is rational. That means we can write it as a fraction. Square root of 32 equals p over q, where p and q are integers, q isn't 0, and remember this, they're coprime, sharing only 1 as a common factor. Got it? Let's see where this takes us. As we have assumed square root of 32 is a rational number, therefore square root of 32 equals p upon q. Now let's square both sides to ditch that square root. Square root of 32. Squared equals p upon q. Squared 32 equals p squared slash q squared. Multiply both sides by q squared to clear the fraction. 32 times q squared equals p squared. Whoa. This equation is our first clue. It's telling us that p squared is 32 times q squared. In other words, p squared has to be a multiple of 32. That's huge. Let's dig deeper. Now by this, what is the question trying to tell us? He is giving us a clue that if 32 is multiplied by a number q squared, then p squared will come. Means if we multiply 32 by q squared, then the answer will come p squared. Therefore, by this we come to know that p squared is divisible by 32. Not understood. No problem, let's explain. By taking an example, let's assume that q equals 2, therefore q squared equals 4. Now if we put this value in equation 1, then we get 32 times 4 equals 128. And 128 slash 32 equals 4 means q squared is divisible by 32. And also we know that if square of a number is divisible by a number, then the number is also divisible by it. Gone above head? No problem. Let's take an example. If 100 is divisible by 2, then 10 is also divisible by 2, correct? Let's take one more. 144 is divisible by 3. Also square root 144 means 12 is divisible by 3. Therefore p squared and also p are divisible by 32. Now the step is coming where a majority of students get confused. Let's assume the number from which if we multiply 32 to get p by bx. Confused, yes, you have to multiply 32 by a number to get p by yes. Then let that number be x. Therefore, now from this, what you get 32. X equals p. Now let's put this value in equation 1. 32, q squared equals open parenthesis. 32, x close parenthesis squared. 32, q squared equals 1024. X squared. Q squared equals 32. X squared equation 2. Therefore, now from this, what is the question trying to tell you? He is again telling that q squared and q are divisible by 32. Now here's the twist. We said P and Q are co-prime. They're only supposed to share one as a common factor. But if both P and Q are divisible by 32, they share 32 as a common factor. That's a total contradiction. Like saying two besties who only have one thing in common actually have a whole secret club together. This mess means our assumption that the square root of 32 is rational can't be true. So, square root of 32, and therefore 4 square root of 2, must be irrational. Phew, what a ride. We've just proved that 4 square root 2 is irrational, and we did it like math detectives. Next time you see a number with a square root of 2 hanging out, you'll know it's probably one of those wild irrational types. If you love this math adventure, smash that like button, hit subscribe, and ring the bell for more. Drop a comment. Tell me what math mystery you want us to solve next. See you in the next video.